Working our way through geometry, and we get to polygons. Polygons. Ooh. All right, first off, let me give you a definition. I'll try to explain to you exactly what it is. So a polygon is first word is simple. A simple, and then the second word is closed. So a polygon is a simple closed curve made up of line segments. A simple closed curve made up of line segments. So in other words, we have to have a bunch of line segments. So let me try to show you some of the aspects of line segments. Just look up here in this segment of the screen. By the way, that's a polygon. Actually, I went a little over. But that is a simple closed curve made up of line segments. That would be a polygon. Commonly, we call it a or a rectangle. It's one of the two. If I were to do this, don't write, just watch. If I were to do that, that is a curve, okay? That is a simple curve, and it's made up of line segments, but it's not a polygon. So it's a curve, it's a simple curve, and it is made up of line segments. So why isn't it a polygon? Juliana? Because it's not closed. What does closed mean? Well, it's opened up, right? You can get in there. Can you get in the square? From the outside in? No. From the inside out? No. On the G, can you get into the G from the outside? Can you get out from the inside? Yeah, so it's not closed, and therefore it's not a polygon. It's simple. It's made up of line segments. It's technically a curve, but it's not made up of line segments. How about this one? All right. Is it a polygon? Yes or no? Yes or no? Is it made up of line segments? Is it closed? Is it simple?
No.
Why isn't it simple? Christina?
Because it's not like a square or like a square. Like
Sure, but what disqualifies it from being simple? Ashley?
crosswise.
Yeah, it intersects itself. So the fact that it intersects itself violates the idea of simple. And therefore, that would not be a polygon. So be careful. You have to have all the aspects. Simple and closed, made up of line segments, for it to be a polygon. So if you had something even that looked like this, is that a polygon? No. It's simple. It's closed, but is it made up completely of line segments? No, it's got a curved part, and yet it is not a polygon. All right, got it? It's got to have all the aspects. It's got to be simple, it's got to be closed, and it's got to be made up of line segments if it's going to be a polygon. What it is, I have no idea, because I have zero artistic ability. All right, so simple closed curve made up of line segments. So let's just write a few things so we're clear here. Simple means the segments don't intersect. The only place they come together is at a vertex, at a point. So that's what I mean by intersect. All right, the segments don't intersect. Again, technically they all intersect at the vertices, but other than that, they do not. And then closed means that the curve is continuous. Continuous. Has no beginning or no end. Has no beginning, no end. That's technical, but you know, in practicality, again, if you're in, you can't get out. If you're out, you can't get in without crossing over the line. That's the idea, right? For it to be closed. If you're in, you can't get in. If you're out, you can't get out. If that's the case, it is closed. All right, let's classify a bunch of polygons. You should know a bunch of these. And we're going to classify them by their sides. So take note of the ones that you don't know and work on making sure that you do know them. Everybody knows the first one. It's a triangle. All right, piece of cake. That is a simple closed curve made up of 3 line segments, right? And we call it a triangle. The second one, most people will misname. They'll call it a square. They may even call it a rectangle. They may even call it a rhombus. Though all of those may be true, in classifying the polygon alone, that's not what you say. So what do you call a 4-sided polygon? Say it if you know it. Quadrilateral. 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 We're going to talk about squares and rectangles and rhombus and all that. There's a bunch of quadrilaterals that have more specific names. For example, I'll use the family with the most. She's a kid. But, okay, that leaves a whole lot of possibility, right? Which one particularly? So, you know, a square is one of the quadrilaterals, right? It's particular one, as she is Chloe, a particular kid, right? Got it? Good. All right, most people know 5. Some of your fathers work there, perhaps. 5 is Pentagon. Any mom or dad work at the Pentagon? Oh, we have that many in here? Okay. All right. Or used to? All right. All right. How many work there or used to work there? Currently do or so 1, 2, 3, 4, 5, 6, 7, 8. All right, that's a lot of parents at the Pentagon. All right, and how many of you have been to the Pentagon? Pretty amazing place. I had no idea all the museum type things they have in the Pentagon, but the building is definitely a pentagon shape, and that is the case. Emily? Ooh, okay. Was he anywhere near? Okay. All right. So 6-sided, most people know it's called a 6.
Octagon.
6. Hexagon. 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 Hexagon, 6-sided. 7-sided, I can't draw to save my life, but the program drew it for me, thankfully. Most people don't know 7. Does anybody in the class know 7? I was hoping to raise... Chloe? It is a heptagon. 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 Almost everybody knows 8. It's an octagon. Most common octagon you see every day is a stop sign, right? 9 is really hard to draw. Really. Anybody know 9? Raise your hand. Anybody know 9? 9. Emily? 9. It begins with N. Chloe? It's a nonagon. Nonagon. A nonagon. Most would know 10. You would know it also from an Olympic event with 10 in it. Daniel? It is a decagon. The decathlon is an event with 10, right? You have to do 10 sports for the decagon. Anybody know 12? Does anybody know 12? All right, you got to think of Sound of Music and do, re, mi, fa, sol, la, ti, do. So it's a dodecagon. Dodecagon is 12. They have names for 20 and 24 as well. I think 20 is an isosagon.
Amazing.
And I can't remember 24. All right, and then n is kind of boring. N is an n-gon. N-gon. It's just a variable, right? How many sides? Look, you can have a 77-sided polygon, right? A 77-agon. I don't know. So what? There's no name for it. Not that I teach. Not that I teach now. You got to wait for Mr. B in geometry. All right. Now, every shape on the other side was this kind of polygon. It was this kind of triangle, this kind of quadrilateral, this kind of pentagon, this kind of hexagon, etc. And that's when all sides are congruent and all angles are congruent. Meaning every side is the same size and every angle is the same size. And notice what we do to illustrate that. Because each of the angles of our triangle have a one arc mark, very poetic, that means they're congruent. Any angle in the same shape with the same amount of arc marks is the same size. So all three angles are the same size of our triangle. By the way, all three angles must be how many degrees?
90 degrees.
Each of the three angles is how many degrees? 60 degrees. All right, anyhow, quiet please. And we use a one mark on the sides to show congruent sides. And notice all three sides of the triangle have a one mark. For our square, we need to do our marks there. Somehow I missed my side marks. So notice all four angles are congruent, all four sides are congruent. In our pentagon, let's add arc marks for our angles. Because again, not only are all sides congruent, but all angles are congruent. Does anybody know the word that you use when all angles are congruent and all sides are congruent? It begins with an R. R. Edward? All right, it is a regular polygon. Regular polygons. All sides are congruent, all angles are congruent. And again, please note on the other page, every one I showed you was regular. So let me go back for a second and just take a look. So that's a regular. That's the only one that looks a little different. Actually, that might be the only one that's not regular. Let me deal with the pentagon. Would you agree? Is this a pentagon? 1, 2, 3, 4, 5. Is that a pentagon? Yes. It's a 5-sided, simple closed curve. So made up of line segments. So it's a pentagon, but it's not what we normally think of a pentagon, because we normally think of a regular pentagon, right? Regular is what we normally think of. And again, what is regular? All sides are congruent, all angles are congruent. All right, now we need to classify triangles by their sides. By their sides, yeah, that's what I want. Okay, so the first one we want to talk about is a triangle with no congruent sides. Don't say anything out loud. I want everybody thinking. So take your black and let's mark the sides to show that no sides are congruent. I'm going to give that side a 1 mark. I'm going to give that side a 2 mark. And I'm going to give that side a 3 mark. Therefore, illustrating that none of the sides are congruent. Anybody think they know the name of this one? Christina, give it a shot. It is not. Anybody else? Begins with an S. Kristen? It is a scalene triangle. S-C-A-L-E-N-E. Scalene triangle. That is a triangle with no congruent sides. Now again, you're going to have to be careful in this chapter. My advice to you is read over your notes once each day of the notes we've taken so far to keep this stuff fresh in your mind, because there's a lot of stuff to remember, a lot of terminology. I don't think any of it's difficult, but you have to remember it, and you got to build those pathways. All right, so this one is technically, it's a triangle with, is one with at least 2 congruent sides. Notice the word at least, though. So if it had 3, it would technically still fit this category. Take your arc marks, take your black. This is the common looking way to see the triangle. But again, it could be flipped upside down. It could be rotated on any kind of angle. All of that is possible. And what do we call this triangle, Colby? This is the isosceles. I-S-O-S-C-E-L-E-S. I-S-O-S-C-E-L-E-S. Isosceles triangle. Now take your red. And there's a special relationship on all isosceles triangles. The angles that are opposite the congruent sides are congruent to themselves. So if I go opposite this side, I get to this angle, and I'm going to give it a 1 arc mark. If I go opposite the other congruent side, I get to this angle, and I also give it a 1 arc mark. Those 2 angles are congruent. That's going to allow us to determine sides based upon that. And we're going to do that later on here. Some of the last couple problems we'll figure out degrees of angles. So take your other isosceles, so this angle must be congruent to that angle, right? The angles opposite the congruent sides are congruent themselves. That's a relationship of every isosceles triangle. The angles opposite the congruent sides are congruent. All right, and then you guys know this one with 3 congruent sides. Technically, this triangle is also an isosceles triangle, but more specifically, it is, of course, an equilateral triangle. Equilateral. L-A-T-E-R-A-L. Equilateral. Have you ever heard of an equiangular triangle? Honestly, this triangle is also equiangular. Because again, remember, the angles opposite any congruent side are themselves congruent. However, if I were naming it according to the sides, I wouldn't say equiangular. I would say equilateral. If I were naming it according to the angles, I would call it equiangular. All right? Depends on how you're naming it. And technically, it's also an isosceles triangle, and guess what? They're all triangles. All right, classifying triangles by their angles. Angles. So the first one is a triangle with 3 acute angles. Very nice, slim and trim. And so she's what? She's acute. All right, she's an acute triangle. An acute triangle has 3 acute angles. If all 3 angles of a triangle are acute, then it's an acute triangle. That means all 3 have to be less than 90 degrees. Only way. All 3 less than 90. Well, what if you have a triangle with a right angle? We all know that this is, of course, a right triangle. You would be right, and we don't want to spend any time there because you all know that. And therefore, then, if it's going to be an obtuse triangle, how many obtuse angles will there be? Well, I got news for you. There can only be 1 obtuse angle. Because remember, the 3 angles of any triangle add up to 180 degrees, and the only way, therefore, to get an obtuse triangle is if one of them is bigger than 90. You can't have, what if two of them were bigger than 90, you would go over the 180, wouldn't you? You'd have too many degrees. Three angles of a triangle is always 180. All right, what about a problem like these two here? We'll end up today with these. Oh, by the way, you can recognize which of the angles is the obtuse angle, right? Can you see it? Looking at the figure. Go ahead, from the word obtuse, draw an angle to where that obtuse angle. Draw an arrow to where that obtuse angle is. Draw an arrow. And I hope you went there, right? That angle is the obtuse angle, right? And again, the triangle can be spun any which ways. All right, notice I have 3 asterisks at number 5. I've mentioned this a moment ago. Key concept, for every triangle, the sum of the measures of the 3 angles is 180 degrees. And we mean, of course, the interior angles, the angles inside that make up the triangle. So if you were given this triangle for A and we're looking for the measure of angle 1, you would say, okay, that's easy. I start with 180, subtract the 95 and subtract the 35 and see what's left. And therefore the measure of angle 1 has to be how many? Again, you got a calculator. If you can't do it in your head, punch it out in your calculator. Chloe, it is 50 degrees. It's got to be. Now, by the way, we can begin to do stuff with parallel lines and transversals and stuff, right? Corresponding angles. I can stick a triangle as part of all of that, and you could figure out the other angles. On B, it's a little different. We have an isosceles triangle. Now, this isn't the number of degrees. This is a label. So that angle's not 7 degrees. It's what we're trying to find. So how in the world are we going to find the measure of this angle? Well, first off, you have to note that it's what kind of triangle? Isosceles. And what special relationship did I tell you about an isosceles triangle? Luke, what did I say? The 2 angles, right, opposite those sides are congruent. So this angle and this angle are congruent. They're both congruent. Now, these you can do in your head, but if we were going to write an equation, this is how I would write it. 2 times the measure of angle 7. And the reason is both of these angles are the same, right? 2 times the measure of the angle 7 has to be 180 minus the 25. Has to be. Because whatever's left over from the 180 minus the 25 has to be 2 times measure of angle 7. So watch how this finishes out. 2 times the measure of angle 7 equals, and what is that, 155? Gave a fun one, didn't I? 155. And look, this is just a little equation. Things multiplied times the variable. You move by multiplying by the reciprocal. See, the point is there's 155 degrees left, and half of it's for angle 7, and the other half is for the angle on the other side, right? Because they're the same. So you're just figuring out a way to figure out the halves. So what do you get? You get 77.5 degrees, or 77.5 degrees. And again, you can just punch that in your calculator. Now don't pack up. I want to do one more thing before you guys are done. Now, if this number's a little bit more conducive, it's easier to figure these out. So, don't do this in your notes, but what if instead of saying this was 25, what if I said that was 40? how many degrees are left for the other two angles? If that's 40, how much is left? 140, correct? Because all three add up to 180. So if there's 140 left for the other two angles, each of them must be how many? 70, right? It would be easy if it's something like that. If this angle were 80, how much is left for the other two? 100. So each one must be 50. Now, there's one other way we can do this problem. So again, just hang in there. We're almost done. But I could also do this problem this way. All right, forget about the 25. What if I told you the measure of angle 7 was 20 degrees? Can you tell me the measure of this big angle up here? Let him think for a second, Edward, and then I'll come to you. So it's an isosceles triangle. This angle right here is 20. What's this angle up here? Raise your hand if you think you got an idea. All right, Edward, what do you think? Just say the answer and we'll see if they agree.
140 degrees.
How many agree with Edward? 140. And Edward's correct because here was his logic. If that's 20, this one's 20, and what's left for the big angle? 140, right? So we could also give the problem in that kind of relationship. All right, remember, a polygon has to be simple, closed, made up of line segments. And don't forget, listen, don't forget regular. All angles are congruent, all sides are congruent. All right, you got your homework. Hope you do well tonight.